This is Newton's third law of motion. So far we've seen in Newton's first law that an object will stay in a situation of constant velocity. It will maintain a constant velocity unless, let's put down constant velocity, unless an unbalanced force acts upon it. That was the gist of the first law. And so what that basically means is that forces cause acceleration. They cause velocities to change, acceleration. Okay. So the first law, good. Then in the second law, we learned that there's a mathematical proportion, or what we call a formula, where we use the word net to describe the total number of forces acting on an object, and the total forces acting on an object will cause that object, or the mass, to accelerate at a particular rate, and so we can actually calculate that. Now on to the third law, which we'll talk about in a little more detail. The third law is commonly written like this: for every action force, there is an equal and opposite reaction force. So we'll talk a little bit about what that actually means. Well, what it means is that we think about something causing a force, and we think about something else sort of receiving that force. But that's not what Newton realized is actually true. The way I like to think of this law is a slightly different way. I like to think of it as forces exist between objects. Between objects. And it doesn't matter who's doing the forcing or who's receiving the forcing, so to speak. So here, let's do a little example of that. Let's take, I'll try and draw a little picture here. Let's take this cowboy who is standing here in the saloon, and this other cowboy sort of standing over here. He'll get the black hat because in the old movies the bad guy always wore the black hat, the good guy wore the white hat. And this guy is taking a swing with his fist at this other cowboy, the classic saloon fight. And so in the cartoons they put a thing here and they would say "BAM!" as he punches this guy in the face. So let's draw this a little bit differently. Here's the face, and here is the fist as it approaches the face. Now we like to think about the fist striking the face with a particular force, and it looks like this face is really doing nothing. It's just standing there getting the force. But I want you to think about what would happen if you had a fist that was just being held still, and somebody was racing towards the face or towards the fist really quickly and smashed their face into the fist. What would be the difference between these two things? And Newton's third law tells us absolutely nothing. The difference between a fist hitting a face or a face hitting a fist is exactly nothing. And so in the case of the fist hitting the face, we would call this the action force. And Newton's law says that if that's true, then the face would also hit back with the very same force, and that would be the reaction force. So you see how I like to think that the force exists in between these two objects, and both of them will feel that force the same way. And as we get into problems about motion, that force would cause the same kind of motion in both objects, depending upon their masses. But if you want to, you could easily consider a face as the action force running into a fist. And that would mean that the fist would push back against the face with exactly the same force, except we would call it the reaction force. So the words action and reaction are really just ways of describing what is applying the force and what is receiving the force. But Newton's law says that really doesn't matter. It says that the force exists between the two objects, and they would both feel the force. So in the movies, when the cowboy hits the other guy in the face, this guy here usually falls down, and this fellow stands up and runs off, punches someone else, or wins the fight. But in reality, if you think about what's happening, the skull of this cowboy is made of very thick bone. And the bones of a hand are very, very thin, very tiny, and easily broken. And so if he punches this large, massive skull, then his fist is going to feel exactly the same force as the face feels, which means he might break a finger or two. And in reality, if you ever try to punch someone in the face, you better be prepared for some broken fingers. Because it would be the same as taking this big, heavy skull and smashing it against your hand. You can bet that there would be some bones broken if that were the case. And so this particular law is trying to get us to understand that forces exist between objects. One might be the action and one might be the reaction, but the force is the same. Let me give you another example that helps you understand how important reaction forces can be. Let's take the ground and let's draw the wheels of a car. All right, there's a car. Let's make this a very pathetic drawing of a car. I drew it this way because the car obviously is going to go this way when it travels down the road. Now let's think about which way the wheels would turn if a car was going this way. Well, we know that. They would turn this way in a clockwise manner. Now let's look very closely at what's happening between the wheels and the road. The wheels are pushing backwards against the road. Well, Newton's law, Newton's second law, says that F equals ma. So if you push to the left with a negative force, guess what? You're going to cause a negative acceleration. You're going to cause an object to speed up to the left. But how does that make the car go forward? The wheels, in fact, don't make the car go forward. The wheels produce an action force against the road, but the force of friction on the road pushes back with the exact same force. Friction is the reaction force, in this case, of the wheels pushing on the road. And that force is going to the right. And so it's the reaction force that actually makes the car accelerate forward. It makes the car go. Without the road, you could spin the wheels all day long and the car would not go. If I took this car and I put it up in the garage on a hoist so that it was stuck up high, you could spin the wheels as much as you wanted to, but with no road underneath them and no friction, there would be no movement of the car whatsoever. And so the car relies on the reaction force. It pushes against the ground, but the ground, because of the friction in the tires, is what pushes the car forward. So it's also just as good to think of a force being created between the wheels and the ground. A force that the wheels are technically applying to the ground, but the ground is also pushing back with the same force. So that force that's applied exists between the wheels and the ground. So Newton's third law tells us that we have action and reaction forces, and they are equal and opposite, and forces actually exist between objects, and it doesn't matter which one is doing the applying or which one is doing the reacting.